clock speed, cores, threads. Here is your same structured, beginner-friendly content for clock speed, cores, threads, CPU performance fundamentals, intermediate level, introduction. When comparing CPUs, you often see terms like gigahertz, clock speed, number of cores, number of threads. These are the key factors that determine how fast a CPU can perform tasks. At the intermediate level, understanding these concepts means learning how CPU speed is measured, how multiple cores improve performance, how threads allow multitasking, how these factors work together. Understanding these concepts helps you choose the right CPU, understand real-world performance, avoid common misconceptions, optimize systems for different workloads. What are clock speed, cores, and threads? These three concepts define CPU performance. In simple terms, clock speed means how fast a CPU works per cycle. Cores means how many tasks can run in parallel. Threads means how efficiently each core handles tasks. Example concept. Speed plus parallelism plus efficiency means CPU performance clock speed, gigahertz. What is clock speed? Clock speed measures how many cycles a CPU can perform per second. It is measured in gigahertz, gigahertz. 1 gigahertz equals 1 billion cycles per second. 1 gigahertz equals 1 billion cycles per second. How clock speed works. Each cycle represents a step in instruction processing. Higher clock speed means more instructions processed per second, faster execution in many cases. Example concept. Higher gigahertz means faster instruction execution. Important note: clock speed alone does not define performance. A CPU with lower gigahertz can outperform a higher gigahertz CPU due to better architecture, more cores, larger cache, better efficiency, CPU cores. What is a core? A core is an independent processing unit inside the CPU. Each core can execute its own instructions. Example concept. One CPU means multiple cores, means parallel processing. Why multiple cores matter? More cores allow the CPU to handle multiple tasks simultaneously. Example. 1 core means handles 1 task at a time. 4 cores means handles 4 tasks in parallel. Example concept. More cores means better multitasking. Types of workloads. Single core workloads, simple programs, older software, some games. Multi-core workloads, video editing, 3D rendering, programming builds, AI and data processing. Threads. What is a thread? A thread is a sequence of instructions that a CPU can execute. Each core can handle 1 or more threads. Example concept. Core means executes threads, means completes tasks, multi-threading. Modern CPUs support simultaneous multithreading, SMT, e.g., hyperthreading. This allows 1 core to handle multiple threads. Example concept. 1 core means 2 threads, means improved efficiency. Why threads matter? Threads help improve CPU utilization. Instead of staying idle, a core can switch between tasks, handle multiple instruction streams, relationship between cores and threads. Each core can run 1 or more threads. Total threads equals cores times threads per core. Total threads equals cores times threads per core. Example. 4 cores, 1 thread each means 4 threads. 4 cores, 2 threads each means 8 threads. Real-world CPU example. Example CPU. 6 cores, 12 threads, 3.5 gigahertz. Example concept. 6 cores means parallel tasks. 12 threads means efficient multitasking. 3.5 gigahertz means fast execution per core. How these work together. CPU performance depends on all 3 factors combined. Performance equals clock speed times cores times efficiency. Performance equals clock speed times cores times efficiency. Scenario 1. High clock speed, few cores. Great for gaming, good for single-thread tasks. Scenario 2. Many cores, lower clock speed. Better for multitasking, ideal for heavy workloads. Scenario 3. Balanced CPU, best for general use, good mix of speed and parallelism. Analogy, easy understanding. Think of a CPU like a restaurant. Clock speed means how fast a chef cooks. Cores means number of chefs. Threads means how efficiently each chef handles orders. Example concept. More chefs plus faster cooking means more meals prepared. Common misconceptions. Higher gigahertz always means better CPU. Not true. Architecture matters. More cores always better. Depends on workload. Threads equals real cores. Threads improve efficiency, but are not equal to physical cores. Performance bottlenecks. Even with strong CPU specs, bottlenecks can occur. Example concept. Fast CPU plus slow RAM means limited performance. Other bottlenecks. Poor cooling means reduces clock speed, insufficient RAM, slow storage, boost clock versus base clock. Modern CPUs have two speeds. Base clock, normal operating speed. Boost clock, higher speed under load. Example concept. Heavy task means CPU boosts clock speed, thermal and power limits. Higher clock speeds and more cores generate more heat. Example concept. More performance means more heat means cooling required. If overheating occurs, CPU reduces speed, thermal throttling. Concepts learned. Clock speed means how cores enable parallel processing, how threads improve efficiency, how CPU performance is calculated, how workloads affect performance needs. Advantages. Understanding these concepts helps. Choose the right CPU, optimize system performance, understand benchmarking, avoid buying mistakes. Example concept. Right CPU choice means better performance for your tasks. Challenges. Common difficulties include misunderstanding gigahertz versus cores, confusing threads with cores, ignoring workload requirements. Example concept. Wrong understanding means wrong CPU choice. Simple definition. Clock speed, cores, threads. The key factors that determine CPU performance, where clock speed defines execution speed, cores enable parallel processing, and threads improve efficiency. Final summary. Clock speed, cores, and threads are the three fundamental factors that define CPU performance. Clock speed determines how fast each core can process instructions. Cores determine how many tasks can run in parallel, and threads improve how efficiently each core handles tasks. A balanced combination of these factors provides the best performance depending on the workload. Understanding these concepts helps users make smarter decisions when choosing or optimizing a computer system.